Hi you guys! So in this video we're sort of just going to do some practice with different problems that deal with similar polygons, sort of get familiar with using the different elements of them to find missing values and just answer questions about them in general. So in this first question it says, assuming that ABC is similar to HFJ, so remember when we have the little squiggly line, that means that the two shapes are similar. So it wants us to find the scale factor from ABC to HFJ. So remember the direction that we're going matters. And so this one wants us to go from this big shape of ABC to the smaller shape HFJ. So remember our way of finding that is we can use a little equation. So sort of a shortcut way you can write it is if we're going to go from big to small, we can use this equation of big side length times x equals small side length. And alternatively, if we're going from small shape to big shape, then we can use a small side length times x equals big side length. So this is a little shortcut of how we can find the scale factor, with the scale factor being the x of these respectively. So as we said, that it is asking us to go from this big shape to this little shape. So the next thing we need to determine is we need to determine which of these are corresponding sides that we can use these equations respectively, because remember these have to be corresponding sides that we're comparing. So if we look at this, it says that AB, so remember that we're going in the order that it gives us. It won't always give us the letters in alphabetical order, and so sometimes that means that it's written in a different way, but we need to go off of the order that it gives us in order to determine what is corresponding. So for this first triangle, we have AB, and on the second one, we have HF. And so that means that these two sides are in fact similar. So what do we do with this? So we are using this one over here because we're going from big to small. And so we have the side lengths of 10 and 4. So our big side length is 10, so that means we're going to do 10 times x equals our small side length, which is 4. So if we do that, then we would divide both sides by 10, which would end up getting us x equals, so that'd be 2/5, or we could write it as equals 0.4. Those would be equivalent. Now we could have used a different set of corresponding sides, so if we had used BC and FJ, we can see from the order that those two are corresponding, it would have been 15x, because 15 is from our big shape, and then equals 6, because that's from our small shape. So again, we would do the process. X, we divide both sides by 15, which would get us 6 over 15 is the same as 2 over 5, because they're both divisible by 3, which again is 0.4. This shows us that regardless of which of the corresponding sides we use, it always gives us the same value. Now, say if it had asked us to go from HFJ to ABC, then we would have used this other one, which, let's say we were going to use these two sides for that, then we would have had 4 times x equals 10, and then if he divides both sides by 4, we end up getting x equals 5 over 2. So So we see that we end up getting a different ratio when we go from the other direction. Though it is handy that it is the reciprocal, not the negative reciprocal, but just the reciprocal of the previous relationship. So that can help us get a better idea of what our relationships are between the shapes. Again, we can use a rule of thumb that if we're going from big shape to small shape, that means our factor is going to be less than 1. And if we're going from small shape to big shape, like we were doing on this one, our scale factor is going to be greater than 1. So now number 2. So this one wants us to find the perimeter of HFJ from number 1. So we want to find the perimeter of this one. So there are a couple of ways that we can do this. So as we had talked about in the last lesson, we can end up finding missing values from similar triangles using proportions. So let's say that this side length right here is t. And so if we wanted to find that value, well, we can see from our relationships that so CA or AC, depending on what order you want to say it in, is proportional to JH. And so we could write that as a proportion. So that's 7.5 over T is equal to, and one of our other relationships, so we do have 10 and 4 as we previously identified as corresponding sides, so we can use those, making sure that we keep sides from the same shape in the same placements. So we had the bigger side over the smaller side, so that means we need to continue to have bigger side of 10 over the smaller side of 4. So now this is a proportion. In the last few weeks we've been learning about solving proportions, so we can go ahead and do that. We can do cross multiplying. So we'd have 10 times t equals 7.5 times 4, which is a nice number of 30. And then to find t, you divide both sides by 10. And you end up getting t equals 3. And so now that we know that t equals 3, we can plug that in there, and then we could add these up. So 3 plus 4 is 7, plus 6 is 13. So the perimeter ends up being 13. So that's not too bad. However, there is a second way that we could have found this. We can go and count up these sides. So you have 10, 15, and 7.5. So what's that going to look like? That's going to be 25 plus 7.5, which will be a perimeter of 32.5. So, as we had learned in the previous video, one of the theorems of this lesson is that the relationship or the ratio of the perimeters between two similar shapes has the same ratio as the relationship between the side lengths. So what we could have done alternatively is, since we know that this one is 32.5, we could have a ratio of 32.5 over P for perimeter, because we don't know what the perimeter of the smaller shape is yet. Well, we do, but let's say we didn't. And that equals, so we can use the same side length ratio, so 10 to 4. So now we have a proportion, and so then we can solve it, so we end up having 10p so we have 10p, equals, so we can do 32.5 times 4, which will end up a nice 130, which if we divide both sides by 10, will end up getting us P equals 13. And as we found up here, that is what we got. So you can use either of these methods to help you find the perimeter. It'll end up coming out the same for either one. Personally, I like the second method just a little bit more just because it's one less step. But that extra step isn't too bad, so if you want to do that one, then that's perfectly okay. And it's not that much more. All right, one more problem for this one. So as we're looking at this, it wants us to find x and y, assuming that these two shapes are similar. And so first thing we need to do is you need to recognize corresponding sides and corresponding angles. So our A and Q are first, it means those are going to be corresponding. C and Y are corresponding. D and W are corresponding. G and T are corresponding. And then the respective sides that share those angles will also be corresponding. So we know that AC, so this one right here, is going to be proportional to QY, which is the one right here. As you might notice, our shapes do not have the same orientation, but when we're doing similar shapes, their orientation doesn't matter. All that matters is that they're the same size. So remember, like with congruence, their orientation doesn't matter. So similar with this, all that matters is that this has the same shape. After we recognize these corresponding sides and corresponding angles, we can use some of the rules that we've learned in order to help us find these missing values. So as we see up here, G and T, those are corresponding angles. And remember that with similar shapes, if they're corresponding angles, then that means they're going to be congruent. So if we want to find what x is, we can set these two angles equal to each other. So it's going to be 42 equals 3x, which then we can divide both sides by 3, which will end up getting us that x equals 14. So that one was pretty easy. Then it wants us to find the y. So we see that we have a y here, y plus 5. So, as we've been talking about, the corresponding sides have proportional relationships to each other. So if we want to find this y, we can use those proportions to help us calculate this. So, as we see up here, AC has a ratio, is the corresponding side to QY. So that means that those are going to be one ratio. So if you have y plus 5 over 15, and that equals, so we're only given two other side lengths, so that makes it easy, but we can find that CD right here is corresponding to YW, so that means that these two will have the same ratio. So we end up having 4, because we put the AC first, so that means we have the CD first for this one as well, and then 5 on the bottom. So now this is just proportion, so then we can solve this. So that's going to be a 60 equals 5y plus 25. Then we subtract both sides by 25, which will end up getting us 35 equals 5y, which then, if we divide both sides by 5, we end up getting that y equals 7. So that's not too bad. Setting up the proportions can be a little difficult sometimes, but always go back to the order of the letters that I give it to you in, and that'll help you know which sides are going to be proportional and are corresponding, and which angles are going to be corresponding. So that's the general idea for this. You can go through these again, make sure that you have an understanding of why I did everything. If you have any questions, let me know. Other than that, have a great day. Bye.